Hello learners, this is teacher Sharon and I'm taking you through Form 4 Mathematics. This topic is matrices and transformations and we are going to discuss the subtopic stretch. Welcome. By the end of this lesson, you should be able to find the matrix of transformation given a description of a stretch. Number 2, you should be able to distinguish between the isometric and non-isometric transformations. A stretch is a transformation which enlarges all distance in a particular direction by a constant factor. A stretch is described fully by giving the scale factor and the invariant line. For example, using a unit square, find the matrix of stretch with y-axis invariant and scale factor 3. So we are using a unit square to find the matrix of the stretch whereby y-axis is invariant and the scale factor is 3. So we draw our unit square. Here we will have A, then 1 1, which is B. We have C at 1 0, and lastly D at the origin, that is 0 0. So when we join these points, we make our unit square. Now we are told that the y-axis is invariant, so we are not going to stretch the line AD, but we are going to stretch or to enlarge the line AB and DC because they are lying on the x-axis and AB is parallel to x-axis, so it will be stretched. But for AD, which is lying along the y-axis, it is invariant or it is fixed. So when we stretch by a factor which is 3, then it means that the distance AB we multiply by 3 to get the new distance. And if we multiply 1 unit, that is from A to B is 1 unit. If we multiply by 3, then it's supposed to go to 3. So our B prime will be at 3 and the distance DC is 1. When we multiply by a factor which is 3, then it should be 3, so it means that we have to move C to 3. Then our new coordinates for B prime will be at 3 1, and new coordinates for C prime will be at 3 0. So we can get the matrix of transformation if we assume that it is a 2 by 2 matrix, which is A, B, C, D. We multiply by the object coordinates, that is B and C. So we'll have 1 1 and C, which is 1 0. Then this should take us to the image coordinates, that is B prime, which is 3 1, and C prime, which is 3 0. So if we take the first row and the first column, we'll have A, that is A times 1 is A plus 1 times B, which is B, to give us the first x coordinate, which is 3. Then we have the first row and the second column, where we'll have A times 1, which is A, plus B multiplied by 0, which is 0, will be equal to the second x coordinate, which is 3. So this means that the value of A is 3, and therefore the value of B will be equal to 0 from the first equation, that is equation 1. Now if we want to get the value of C and D, we take the second row multiplied by the first column, should give us the first y coordinate, which is 1. So we have C multiplied by 1, which is C, plus 1 multiplied by D, which is D, is equals to 1. Call that equation 1. Again, taking the second row multiplied by the second column, it should give us the second y coordinate, which is 0. So we have C multiplied by 1, which is C, plus D multiplied by 0, which is 0, is equals to 0. So this implies that C is equal to 0, and therefore D from equation 1 will be equal to 1. So the matrix of this transformation is, for the value of A, 3, value of B is 0, then the value of C, which is 0, and D, which is 1. From our working, we have noticed that the matrix of the stretch with the y-axis invariant and the scale factor k is given as k0, 0, 1. So let's look at this one. We have k as the scale factor, which is 3. From our example, the scale factor is given as 3 and the y-axis is 3. So we are told in general, if we have a stretch with the y-axis invariant and a scale factor k, then it should be written as k 0, 0, 1. So this means that our matrix of transformation was supposed to be 3, 0, because our scale factor is 3, and then 0, 1. And that is true because that is what we obtained as our matrix of transformation. And the matrix of a stretch with x-axis invariant and the scale factor k is supposed to be given by this matrix, that is 1, 0, 0, k. So these ones will interchange. If the x-axis is the one which is invariant, then the scale factor of the stretch will go to this side, and if it is the y-axis which is invariant, then the scale factor is on the first position. Note number 2, if k is greater than 1, then it is a stretch. Roman 2 under the note number 2, if k is less than 1, it is a squish, but we still call it a stretch. So it's like it has been compressed, but we still call it a stretch. And lastly, if k is equals to 1, then this transformation is the identity transformation, that is, it has no effect. Let's also look at isometric and non-isometric transformation briefly. We say that isometric transformations are those in which the object and the image have the same shape and size. In short, we do not affect the shape and the size of the image or the object when we are doing the transformation. And in simple term, we say that the object and the image are congruent. Examples of isometric transformations include rotation, reflection, and translation. On the other hand, non-isometric transformations are those in which the object and the image are not congruent, or they differ in shape, size, etc. So we have such kind of transformations includes shear, stretch, and enlargement. When we enlarge an object, then its size is changed. If we carry out a shear on an object, then it means that its shape is changed. A stretch will also change the shape and the size of the object. So that is it for this lesson. Thank you for listening.